Welcome back, mathematicians. In this video, we are going to learn about the composite functions when they involve inverse trigonometric functions. So let's start with the properties of inverse functions, and I'm going to talk about these in general terms and then briefly discuss specifically the three trigonometric functions we're using. So first, if you have the inverse function of f of x, this is equal to x only if x is in the domain of the inside function, which in this case is cosine, sine, and tangent. For cosine, this means that x must be between 0 and pi inclusive. For sine, it means it needs to be between negative pi over 2 to pi over 2 inclusive. And for tangent, it means it needs to be from negative pi over 2 to pi over 2, not inclusive, because tangent is undefined for negative pi over 2 and also pi over 2. The other composite function that you might work with is the function f of the inverse function of f of x, and this again can simplify to be equal to just x. However, x must be in the domain of the inside function, which in this case is the inverse cosine, inverse sine, or inverse tangent. So in the case of cosine, x needs to be between negative 1 and 1 inclusive. For inverse sine, x also needs to be between negative 1 and 1 inclusive. For tangent, x just needs to be an element of the set of real numbers. Let's use this information to find the exact value of each expression. Let's start with inverse sine of pi over 15. First, we must consider the restricted domain of the inside function, which is sine. We know that x must be greater than or equal to negative pi over 2, but less than or equal to positive pi over 2. Because pi over 15 is within that restricted domain, we can safely say that the result, or after simplifying, we will get pi over 15. Let's now look at sine of inverse sine of negative 0.4. We look at the inside function and the domain of the inside function. This is going to be x is greater than or equal to negative 1, but less than or equal to 1. So if this value is between negative 1 and 1, then the result is x. Because it is within that domain, we can safely say that the result, or after simplifying, we will get negative 0.4. Finally, we're going to find the inverse cosine of 5 pi over 4. We're going to look at the restricted domain of cosine, which we know is going to be greater than or equal to 0, but less than or equal to pi. Because 5 pi over 4 is not within that domain, we cannot safely just resimplify to get 5 pi over 4. Instead, we have to take an alternative strategy. Now, there are probably numerous strategies to doing this, so this is just one of the strategies to simplifying this expression. First, what I will do is evaluate cosine of 5 pi over 4. Now you can do this by using your unit circle or drawing yourself a picture, but either way you do it, you're going to get a value of negative square root of 2 over 2. We are now going to replace the expression cosine of 5 pi over 4 with the value of negative square root of 2 over 2. This will give us the inverse cosine of negative square root of 2 over 2. We will let this equal to a variable, and because I used x earlier, I will continue to use x. And then I will take the cosine of both sides to get negative square root of 2 over 2 is equal to the cosine of x. We are being asked what angle, when evaluated for cosine, is equal to negative square root of 2 over 2. You can use your unit circle to find the angle x, and in doing so, you're going to look at either quadrant number 1 or quadrant number 2 because x is being defined as greater than 0 but less than pi inclusive, or you can draw yourself a picture to illustrate what you are looking for. To do this, I will put the initial side on the positive x-axis. Terminal side will go in quadrant number 2 because, again, I'm only defined for quadrants 1 and 2. And because the ratio is negative and cosine is negative in quadrant 2, that's why I'm putting the terminal side in quadrant 2. I know that the adjacent side will be negative 1, the opposite side will be positive 1, and the radius is square root of 2. That means that my reference angle is pi over 4, and so this angle, which we labeled as x, is equal to 3 pi over 4. So for my final answer, I have x is equal to 3 pi over 4. So even when the angle is not part of the restricted domain, there is still a way to simplify the expression. All right, guys, good luck.